Hello everyone, welcome back to MrMiers Math channel. In our chapter on radicals and exponents, we're also going to be talking about function operations and compositions of functions in section 7.4. All right, so let's get into it. Obviously, there's many different careers and many different applications to functions. You know, physicists, forensic scientists, actuaries, doctors, pharmacists, paleontologists, and so on. Computer programming also is another huge one that uses a lot of different functions in order to compute values and do other types of operations. Okay, so what we're going to be talking about is operations of functions. Okay, so one thing that we can do is add, subtract, multiply, and divide two functions. All right, so if we say function one is f of x and another is g of x, we could make a new function called h of x, you know, by adding, subtracting, multiplying, or dividing. All right, and using this function notation like we see on this example is very useful when talking about different types of functions. All right, instead of actually saying what the function is, you know, function, you know, x squared plus 4 minus 3, and another function, you know, x cubed plus whatever, we can just simply assign a name to that function. So we could call one function f, we could call another function g, another function h, and it's a lot easier to compare these functions and talk about these functions. We could just say, hey, function f is doing this, whereas function g is doing that, and that's a little bit simpler. All right, so the domain of h consists of the x values that are in the domains of both f and g. And you can see when we're talking about division here, when h involves division, the domain does not include any x values for which the denominator would equal 0. So if g of x equals 0, that would not be in the domain of the function. So we're going to talk about the domain also. All right, so in example 1, part A, we're just going to figure out what would f of x plus g of x be. If f of x is 4x squared and g of x is x plus 1, to create that new equation or new function h, we're just going to add these two functions up. All right, and that would give us 4x squared plus x plus 1. All right, so that would be our new function h of x, and the domain of that function would be all real numbers. All right, for part B, if we write f of x minus g of x, note that we are subtracting the quantity x plus 1, so we have to distribute that negative. We'd get 4x squared minus x minus 1. And once again, the domain would be all real numbers. All right, if there's no denominator here, there's no values of x that are going to make the function undefined. All right, moving on to example 2. All right, let's check out multiplication and division. All right, so now let's say f of x is x cubed and g of x is 2x. If we want to write f of x times g of x, that's x cubed times 2x. And of course, we could simplify this, and that would be 2x to the 4th. And that would be our new function. And then for part B, notice f of x is in the numerator, and then g of x is in the denominator. So that would be x cubed on 2x. And one of the things that we'd want to do is simplify this. And to simplify this, we would take out that common factor. In the numerator and denominator, there's a factor of x that we could eliminate. All right, and that would leave x squared in the numerator and 2 in the denominator. And by simplifying, we see for the domain that changes things. Okay, there's no values of x that would make the denominator 0, so the domain in this case is all real numbers. All right, the domain in example 2, part A, was also all real numbers. I forgot to put that. And then in part C, we have g of x in the numerator, f of x in the denominator, and once again, we have a common factor that can be canceled out. And that would simplify this to 2 over x squared. And now there is an x value for which the domain is 0. if we set the denominator equal to 0 and solve, we would get x equals 0. So the domain is all the real numbers except x. X cannot be 0. And that's one way that we could write that. Okay, now let's talk about compositions. Compositions are a little bit different than just function operations. Okay, a composition is basically one function in the other. All right, the composition of f with g is written as f of g of x, and that's how we read it aloud, f of g of x, and it can be written two different ways. So in this next example, if we call f of x 2x and g of x 5x plus 3, we could evaluate f of g of 1, and all that means is let's plug 1 into function g, and with whatever that value we get, we're going to plug that into function f. All right, so first, g of 1 would be what we get when we plug 1 into this function. So that's 5 times 1 plus 3, which would be 8. Now we're going to plug in that output value into function f. If we plug that value into function f, we'd get 2 times 8, which would then be 16. All right, so it's just saying plug 1 into g, and then with whatever we get, plug that into f and find that output value. So multiple things happening at the same time. All right, so in example 3, we're going to do the same thing. We may skip some as we go along. Let's take a look at example 3, part A first. All right, so one way to do this is just, in order to find f of g of negative 2, let's first just find g of negative 2. G of negative 2 is going to be whatever we get when we plug negative 2 in for x in that function. That's the opposite of negative 2 plus 6, which is just 2 plus 6, or 8. Now let's take that value and let's plug it into function f. So where we see function f here, we're going to plug 8 in for x. So that's a negative 2 times 8 squared. Now 8 squared is 64, so we get negative 2 times 64, which is negative 128. All right, in example B, whoops, that's not what I wanted to do, erase. In example B, we're going to first take 3 and plug it into f now. So f of 3 is the output value when we plug 3 into function f. We have 3 squared, which is 9. Negative 2 times 9 is negative 18. Now whatever we got for f of 3, now we're going to plug that into g. So that means g of negative 18. So that's the opposite of negative 18 plus 6. So that's just 18 plus 6, or 24. So g of f of 3 would be 24. Now part C looks kind of weird. It says g of 1. That means we're first going to plug 1 into function g, and with whatever we get out, we're going to plug that into g as well. All right, so g of 1 is just negative 1 plus 6, which is 5. Now let's plug that right back into the same function. All right, so now we have negative 5 plus 6, which is positive 1. So g of 1 is just 1. All right, let's move on. Now, some of these get a little bit more complicated, so notice we have some rationals here. This says in part A, f of g of 4. So the first thing that we're going to do is find g of 4. All right, so that's 4 plus 4 over 8, which is 8 over 8, or 1. Now let's plug 1 into function f. So we get 1/2 times 1 minus 7. 1/2 times 1 is just 1/2, and 1/2 minus 7 is negative 6.5. Awesome. Then if we take a look at part B, it says g of f of negative 6. We're using the same functions, but now it's just plugging in a different input and in a different order. We're first plugging negative 6 into f. So that's 1/2 times negative 6 minus 7. 1/2 times negative 6 is negative 3, and negative 3 minus 7 is negative 10. Now, with f of negative 6, with whatever we got out, we're going to plug that into g. So now we're doing g of negative 10. So in function g, we're just going to plug in negative 10 for x. So that's negative 10 plus 4, which is negative 6. And negative 6 over 8 is negative 3/4. Awesome sauce. Now this is evaluating using compositions of functions, but now let's say we just want to create a new function with these compositions. Let's check it out in this next example. So if we just want to figure out what is f of g of x, okay, we're going to take function g, whatever that is, we're going to take that and we're just going to plug it into function f where we see that input value. So in this case, we're getting rid of x and we're plugging 5x plus 3 instead. So that's where we see this. It's 2 times function g. And then we can simplify. If we were doing g of f of x, oops, let's clear the board. We're taking f of x, whatever that is, and we're plugging it into function g. So f of x is 2x. And now we're plugging that in where we see the input value in function g. So that's 5 times the quantity 2x plus 3. And if we simplify, we get 10x plus 3. All right, let's practice this. All right, so in part A of example 5, we have f of g of x. So we're taking function g and we're plugging it into f. All right, so that means this whole thing, 5x plus 1, we're going to plug into function f. We're taking this whole thing, and I like to use parentheses there. We're plugging it right there. So we're going to replace that x with 5x plus 1. All right, so that means we'd have the quantity 5x plus 1 squared plus 3. So now let's simplify. 5x plus 1 squared would be 25x squared, whoops, 25x squared plus 10x plus 1. And then we have this plus 3, and we're going to combine like terms. And we get 25x squared plus 10x plus 4. We also want to state the domain, and in this case, since there's no denominator and there's no variable in the denominator, the domain is all real numbers. Now in part B, we're taking f of x and we're plugging it into function g. So we're taking this whole thing and plugging it in right there, the input value of function g. So we're going to rewrite this function as 5 times x squared plus 3 plus 1. If we distribute 5, we get 5x squared plus 15, and then plus 1. And if we simplify, we get 5x squared plus 16. The domain, once again, in this case, is all real numbers. All right, and then lastly is another one of these funky ones. It's g of x. So we're taking g of x, and this is funky. We're plugging it back into itself. So g of x is 5x plus 1. We're going to plug it back in, right in where we see the input value. So instead of x, we're writing 5x plus 1. So we have 5 times 5x plus 1 plus 1. Let's distribute. So we have 25x plus 5 plus 1. and that would give us 25x plus 6. Lastly, the domain, once again, is all real numbers. Awesome sauce, folks. That's it. If you enjoyed this, if you found this helpful, please like, subscribe, and share. Thank you, and have a good day.